An arrow is launched horizontally with an initial speed of 15 meters per second. What is the velocity of the arrow 5 seconds after it is launched? Well, first of all, I just want to point out a couple of things. Here, we're given the speed, but we know that this 15 meters per second is in fact the velocity. The 15 is the speed. With this information that it's launched horizontally, we know that that is the initial speed in the x direction. The question is asking what is the velocity, which means I'm going to have to provide the speed and the direction for this problem. So we know that the arrow starts somewhere. So let's say that the arrow starts right there. And the arrow is going to follow a parabolic path. So we know that generally that is going to be the path right there. Now we don't know from where the arrow is launched. It's not given, so it's probably not important. All that is important is that the arrow arrives somewhere along this arc. So I'm going to pick this point right here, and I'm going to say that that is the 5.0 second mark in space. And we want to figure out what the velocity is at that position right there. So what I'm going to do is I'm just going to sketch a velocity vector. So the arrow would be pointed down like that. Okay, so let's just expand this diagram. So we have the velocity vector, that's what we're interested in, and it has an x component and it has a y component. And we know that the x velocity is 15 because that's in the horizontal direction. We don't know what VYF is, so that's one thing we're going to have to figure out in order to figure out what V is. And then of course we have to figure out the angle, and the way I drew this triangle, it looks like I'm going to figure out the angle with respect to the x-axis. So this diagram right here represents what's going on right at that point there. So let's list the given information. In the x direction, we don't know how far the arrow moves. We do know that it moves for 5 seconds. We know that the initial speed in the x direction is 15 meters per second, which means the velocity is 15 meters per second. V is equal to 15, it's constant. A is equal to 0 because it's constant. So now the y direction, what do we know? Well, we don't know how far it drops down. We do know the time to drop down is 5.0 seconds. The initial speed in the y direction is going to be equal to 0. The final speed in the y direction, we don't know what that is. And the acceleration due to gravity, because it's falling, is negative 9.8 meters per second squared. Okay, so that's all my given information. So let's, I typically begin in the y direction. I find that more success that way. The problem, I find it easier to reach the solution if I begin with the y. Don't know if that's true, but at least I think that. I'm going to pick this equation, and I'm going to solve for the downward final velocity. The reason for this equation is since I don't know what the y is, I can't use the position function. That's what I like to start with, but it's not going to work this time. So I have to pick something else from my list of formulas. And since I have time, initial speed, and acceleration, this will work for me. So Vy is equal to 0 for the initial speed plus negative 9.8, and it's accelerating for 5.0 seconds. So that product right there will give me the final velocity. I just need to know what is the rate of the acceleration and for how long does it accelerate at this rate, and if it begins by 0, from 0, it's just the product. So Vy is equal to negative 49 meters per second. Makes sense that it's negative because it's going downward. In the x direction, we're going to have, well, we actually, in the x direction, we already know this. So we know that v in the x direction is equal to 15 meters per second, so nothing to calculate. So I'm going to draw that triangle again. We know we're going 15 meters per second in the x direction, negative 49 meters per second in the y direction. So that way I can figure out what v is. So I use the Pythagorean theorem. V squared is equal to 15 squared plus negative 49 squared. So v squared is equal to 15 squared is 225. And this will be negative, or minus. And 49 squared would be 2,401. So if we add that, 2626. I'm carrying extra significant digits as I do this. That's squared. So take the square root of 2626, and v is going to be equal to plus or minus 51. Now I'm rounding to 2 sig figs because I have 15 and I have 49. Now since this is downward, the answer is well, negative 51, but we're going to take care of the, actually that's not really that important. We can just say 51 meters per second. We're going to take care of the direction using the tan function. So we know that's equal to arctan of 49 over 51. 49 divided by 51, opposite divided by adjacent. And that's equal to 73 degrees. And I need to say with respect to a particular axis. So I'm going to say below x-axis. That would be good. Or I can say 73 degrees south of east using the polar coordinate axes.